Assalamualaikum warahmatullahi wabarakatuh. So today I will explain about urinary system. First of all, I would like to apologize because I can't give you the pre-lab class for today, but I will make it into like this. I hope that you understand. If you have any question, you can ask in the group. Okay, let's go to the next one. So in the urinary system, we will talk about like kidneys mostly. And okay, so like urinary system is an important system for removing the metabolic waste of food um, that was produced by the body, especially like nitrogens such as urea, creatinine, and other things. So these systems can filter 180 liters per day, and like the anatomy of the kidneys, this system, which is consists of two kidneys, a pair of ureters, bladder, and also urethra. Okay, for this one, they will talk about the anatomy first. I think all of you have understand about this, so I will just skip about this one. Okay, this one is kidney anatomy, which is like the fun fact is that the right kidney is located lower because they are compressed by the liver compared to the left one. And then this one, the kidney structure, so that they have three regions. The first one is the cortex. Cortex is the one that is the outer one, and also the grainy one, which is contained glomerulus, Bowman's capsule, proximal cortical tubule. And for the medulla is the one, the inner part in here. So that one is darker compared to the cortex, and also they consist of pyramids, papillae, and also the base of the renal. And then we also have pelvis renalis. That one is they have like some kind of like funnel shape, which is to collect the urine itself. Okay, next. Okay, this nephron. Nephron is the functional units of the kidney. So I think you have heard about like if for the nervous system, it has their own units or like cell, which is neuron. But for this one, for the kidney, they have something that called as the nephron. So nephron is consists of two components. And for your information, so like each kidney, it has around 1 million of nephrons. So it is a lot because it is like cells are small, right? Okay, the components, we have the vascular one and also the tubular one. So for the vascular components is actually the blood side of the kidneys, and the tubular is the fluid side. Okay, so this one is like the pathway of that. So like from this, they will go from afferent arteriole, and then they go to glomerulus, and then they go out to the afferent arteriole again. So and then in the pretitubular capillaries, and then for the tubular, they will go from Bowman's capsule, and then they will go to proximal tubule, and then to the loop of Henle, and then the last one is to the distal tubule and the collecting duct. And this one also, they have the combined vascular combined and vascular tubular components, which is the juxtaglomerular apparatus. But we will not not really talking about this one. Okay, and then we will go to this. So kidney has some function. I can say like 4 function in this topic. The first one, the regulatory function. So like they help to maintain water, salt, pH, and also blood pressure. Okay, and then the second one, it's for excretory function. So like they excrete. So like they will like remove this thing. For example, like urea, creatinine, and also toxins. And then we also have some kind like special metabolic function. Well, it has a lot of functions such as activate the vitamin D, and also like to make glucose for someone who is fasting. Like, like when we are fasting, we don't eat any food, right? So but our body still needs the glucose to be the energy for our, I mean, for us, like that. So the things that they did is that they will change the gluconeogenesis into glucose. Okay, and then they also like will break down the hormones. Okay, and then for the last function is that they are also for hormonal function. It is, I think I will just explain about this one. So erythropoietin, they are the one who stimulates the bone marrow to produce more red blood cells, and also to produce renin. Renin is an enzyme. If I'm not mistaken, it's an enzyme that will control the blood pressure. This one, renin, angiotensin, aldosterone, or we call it as RAAS. Okay. Okay, let's move on to the main topic. Okay, for urine formation, we have the mechanism. They actually have some steps, but they start with the filtration first. Okay, filtration. So in the filtration, they occurs in the glomerular capillaries and will goes to the Bowman capsule. Okay, and they also produce the primary urine, or we call it glomerular filtrate. Okay, like can choose between those two things, but usually this one is more familiar with people. And in the primary urine, it contains glucose, salt, sodium, calms, and amino protein. And in primary urine, it is almost free of protein because it has a large, because like I think you have learned this about what this in the last semester about the membrane transport. So that the protein, they have large size, so they are cannot be filtrate. I mean, like they cannot go past through that, so that's why they are not, yeah, you know what I mean. And then this one, wait, okay, wait. Okay, for the filtration barriers, they have three layers. So these three layers. For example, the glomerular capillary wall, which is the fenestrated one that has holes, and then the second one is the basement membrane, which is negatively charged, and it's also repels the protein, and also the podocyte. Yeah, where is that? The inner layers of bone mucosa, which is like consists of podocytes. Okay, they are the one who filtrations, like the filtration slits. So why filtration, in the filtration it doesn't have protein left? Well, not only because of they are having large size of proteins, but also it's because of the basement membrane. They have negatively charged. Okay, so like they have negatively charged that could repels the proteins. I mean, like could repels the albumin. The albumin is also type of protein, so they are being repelled because of that. Okay, go next. And then this one, only 20% of plasma is filtered to at glomerulus. and 19% is reabsorbed, and for 1% is being excreted and will be the urine. So it resulting an average LFG, which is 125 milliliters per minute. Okay, the last, I mean, like in the first page, if I'm not mistaken, it says the 180 hours, sorry, 80 liters per day. Well, it's just the same as this, but it just have different units. Okay, let me explain about this LFG. So what is LFG? Okay, so LFG is the amount, wait, I can, oh yeah. So LFG is the amount of the fluid that was filtrated into the Bowman's capsule per minute of time. Okay, so the normal value is 180 milliliters per minute and or 180 liters per day. So imagine like if you fill a bottle of water which consists of 1 liter, and so like it means that in every 8 minutes it will fill 1 liter, right? So in one day you will have 180 bottles. So like that's a huge numbers of, yeah, amount, yeah, you can see. But here's the amazing part. From this number, 180 liters, only 184 milliliters. I mean, like the 184 milliliters will be reabsorbed, and only 1 milliliter will be excreted. Created. Yeah. Why they absorb again? Because there are many important materials in our blood that could be used again. Okay, next. Oh, wait. Urine. Yeah, okay. Oh yeah, let's go back again. We actually, in this LFG, we have LFG or glomerular filtration rate is the same. LFG, if I'm not mistaken, it is the Indonesian one, which is like laju, right? Laju filtrasi glomerulus. But we can also use GFR because it's just the same. So this GFR, it has the, what can I say, like the formula, which is KF, and also the net filtration pressure. Okay, sorry. So KF is the filtration coefficient. Filtration coefficient, which is the surface area, yeah, plus the permeability of glomerular membrane. Okay, but for the net filtration pressure, it is the force that push the filtration oh, minus force that opposing the filtration. Okay, Yeah, in here. Let's go back in here again. So what are the factors that actually plays a role in filtration? We have some things in here. So the first one is the pressure, and yeah, the pressure that actually that push the filtration. So this one usually we use plus, okay, to make it easy. So the blood pressure in capillaries normal. I mean, like they will have this number 55 millimeters of mercury. So from here they will go inside like this, but somehow, yeah, not only that, the pressure that also push the filtration, we also have oncotic pressure uh, in the Bowman's capsule, but because they don't have any protein, the number is only zero. So like just ignore that. And then for the pressure that actually against this one, we have two types. The first one is the hydrostatic pressure in the Bowman's capsule, which is 15 millimeters of mercury. So because they are like opposing, just put minus in here. Okay, so and then the second one is the plasma colloid osmotic, which is also minus. Yeah, from this one. Okay, so to get the net filtration pressure, like I said before, the one that push the filtration minus with the one that against it. So 15, 55 minus 30 and then minus 15, which is equal to 10 millimeters of mercury. Yeah, so that's why this one is KF. I forgot which it is, like, is it having their own numbers of how, but for the net filtration pressure is this 10 meters of mercury. Okay, I think I can go again. Wait, let me think. Okay, like GFR. Okay, I will say GFR. Okay, GFR is affected by, if we look at to the formula, it is affected by these two things, the net filtration pressure and also the filtration coefficient. Yeah, for the filtration coefficient is the first surface, and this one, okay, I think we just can go skip. So for the GFR control, so how is GFR is being controlled? Well, they have some types of them. So the first one is renal arterial resistance. Wait, is it the same? Yeah, resistance or regulations of blood flow through the renal arteriole. It's just the same. Okay. In this one, so if the afferent arteriole. Oh yeah, I think you need to know first. Arteriole is the blood vessels that was located before the glomerulus. So they are the one who go. Is it, yeah, glomerulus? And this I mean, like if you look at the anatomy, it starts from the afferent arteriole. They go to the glomerulus and they will go out with the afferent arteriole. So in the afferent arteriole, which is the one that before the glomerulus, if they constrict, so like if they are constrict, how can I say this? Yeah. GFR. If the afferent arteriole is constrict or vasoconstriction, constrict, which is they will go to narrow. If we look at to the last topic we're talking, which is about the blood pressure, if they have a small radius of vessels, the blood vessels, it means they also have a low resistance. If a low resistance, it means they have a bigger rate. Okay, so that bigger rates. And also that, how can I say? Sorry, I was mistaken. So like if it's like afferent material, it means that if it's constrict, they will decrease, but the GFR will also decrease. If it's like dilates or like getting bigger, widens is the same. They will go higher and the GFR also higher. But for the GFR control, auto regulation, actually they have two mechanisms. The first one, the myogenic, which is they use the muscle stretch response. So in this one, the blood pressure will decrease and they will stretch the afferent arteriole, and after that the muscle will contract and the vessel will go narrows and the GFR will go normal again. But for the tubuloglomerular feedback, it is like using the macula densa sense salts. So like the blood pressure is going higher, and then the glomerulus filtrate rate will go higher as well. And the fluid will flow faster, and the less salt will be reabsorbed. And after that, the macula densa will detect the high salt. So and then the afferent arteriole will be constrict. And after that, the LFT will go normal again. And it's very important to know that the autoregulation works between 80 until 180 millimeters of mercury mean arterial pressure, or MAP. Okay. Can see this one. They also have put this one. So okay, the third one is we're also having the hormonal and autonomic nervous regulation. So in this one, if we look at into the type of the stimulation, they have three types. The first one, the low one, which is they are at rest, in the resting state. The effect that will happens on the arterioles that the afferent and also the afferent will dilate. Okay, both of them will be dilates, and because of that, the GFR will become stable. But for the moderate one, they will constrict the afferent, also the afferent, both of them as well. And they will slightly decrease. But for the strong stimulation, they will constrict the afferent only, the afferent more compared to the afferent, and the GFR changes will be large. So like this one is stable, this one is slight, and this one also large. So like why strong sympathetic activation reduce the GFR, where so it's happened because the body prioritize the blood to heart and brain during danger, so that the kidney could wait, because we have learned also the things called as, I forgot what's the name, but you know that the brain, especially the brain, they don't have like some kind of like emergency blood to themselves. So that's why this one is the one that goes to the brain is being more prioritized compared to the other one. And also for you, if you don't know this one, norepinephrine is also types of neurotransmitter. And for this one, let me see. Yeah, the hormone example is the angiotensin second. So for the angiotensin, for example, okay, example. So for angiotensin 2, usually if they will constrict constrict the efferent. Efferent is the one that is after the glomerulus, okay? Efferent arteriole, so that the GFR increase to maintain the filtration pressure, and it could have long-term. Oh, sorry. If this kind of thing happens too much or like long-term, in a long of time, it will cause some kind of damage. But if it's like just regular, but not too much, it's just okay. Next, we will go. I think we will have to look at this one first. Where is okay? This one, the disease that was impaired. Disease with impaired GFR. Okay. You know that the normal one is 125 milliliters per minute, but if it's lower than that, in the stadium one, it is starting from less than 90. It is like when the first nephron, the damage of nephrons is starting. But if it's in the stadium 2, is where from 60 until 89 milliliters per minute, and this also have like still slight nephron damage. But if they are like less than this one, less than 15, it means that they have uremia, which only can be cured with the dialysis. So like for patient for that have a low GFR until more less than 15, it means that they are emergency, so they need to get this dialysis. And also, not only this, there's some also like conditions that like relevant into the GFR. So like if the GFR is abnormal, it could happen this type of disease. The condition. The first one like dehydration. So if dehydration, it means the GFR is low. Why low? Because the low filtration pressure. But for the other one, such as heart failure, GFR also go lower because the low cardiac output will produce the low renal blood flow as well. Okay, there are some other disease, but I think I just need to say this one because you don't need to know this too much about this. Okay, let's go to the next one. Oh yeah, this one. After we're talking about the filtration, we have the things that called as the reabsorption. Yeah, as just like with the names, you know very clear that what the meanings of reabsorption. The reabsorption means that they will, like at first in the filtration they will can I say they do the filtration, and the one that still less is the one that cannot go through is the protein which is have been filtrated. And then in the reabsorption, because the blood that will still go into that part is still high, which is 124 milliliters left. Sorry, not like that. After we filtrate these proteins, we actually need to do the filtration again. So like for the some kind of like important one, we can use it again. Use them again. Okay, this one is the meaning. Reabsorption is the activity to reabsorb the primary urine that's still beneficial to the body. and it has two types. The first one, the obligate. The second one is the facultative. So for the obligate, is this happen in the proximal tubule, or we call it as PCT. But for this one, for the obligate one, they always happen and doesn't have any control. So I mean, like, we cannot control them. But for the facultative reabsorption, it is happen in the distal tubule, which is DCT. It is needs hormone to be activated. With the first one is ABH for the water, and the PTH for the calcium. And after that, they will produce the secondary urine that contains water, salts, urea, and bile pigments that function to give the bile its color. Well, to be reabsorbed, a material actually must pass through the 5 separate barriers, which is luminal membrane, cytosol, basolateral, endocytium, and capillary walls. Okay. Oh yeah, more than 99% of filter plasma will return to the blood. So in average, 124 milliliters of the 125 milliliters filter per minute will be reabsorbed. Oh yeah, what substance that get reabsorbed? This first one, we have sodium, or Na plus. It is located in the PCT, or proximal tubule. How to do it? It is by using the ion channels, and also we have also like sodium and potassium ATPase pump, and then also they have the glucose. Oh, this one, okay. The sodium, they're using the ion channel, and also the active pump active transport, and sodium and potassium, and also ATPase. And for the glucose, they are using the secondary active transport and also facilitative diffusion. Also placed in PCT, okay? PCT, which is proximal. This one is also PCT. And in the urea reabsorption, it is also located in PCT, but using it's just using the passive diffusion. So like the simple one, diffusion, which is just go from higher concentration to the lower concentrations. And then for the last one is the water reabsorption. They are being reabsorbed in the PCT and also in the collecting duct. Yeah, because it is water, the thing's called as aquaporin. Aquaporin is the holes that can only be passed by the water itself. Aquaporin is why it doesn't have any. Yeah, they used aquaporin. Oh yeah, this one, aquaporin, okay. Next. It also have the reabsorption of sodium water. You can just read it because I think it's not. For now, I think you have been explained this in your Kulpak, so I guess you don't need it again. Okay, this one, the hormones that control the reabsorption. We have aldosterone, angiotensin II hormone, antidiuretic, peptide, and others. Oh yeah. Okay, let's go to the most important one, which is the RAAS. RAAS. Okay. What is RAAS? Well, this one is hormone that controls the blood pressure and sodium reabsorption. So what happened? If you have a low blood pressure or like low sodium, your kidneys will release renin. Okay, start with R first. R, it means renin. And what happened with renin? So renin is function to convert the angiotensinogen into angiotensin 1. After that, we go to the second one, which is the ACE, angiotensin converting enzyme. ACE. Yeah. This ACE will be the one who convert the angiotensin 1 into angiotensin the second, or angiotensin 2. What they did? So like, what happens if we actually have the angiotensin 2? This one will be function. I mean, what the function? No, not function. What will cause? The first one is that the blood pressure. The blood vessels. This one is the blood vessels. They will vasoconstriction. So they will make it smaller. And for the second cause is that they will act on the adrenal to stimulate the release of aldosterone, and this aldosterone will tell the kidneys to like reabsorb more, because they have less sodium in water, so like, oh, I need this one from the blood, so like, please did this. Okay, so like, they tell to reabsorb the salt and the water. This one is aldosterone system, as this a system. Now you understand about this, right? Okay, let's go. So there are some drugs that actually that act on the RAAS itself. The first one, the ACE inhibitors, for example, like catalopryl, lisinopril, and others, they will stop the angiotensin second formation. Okay, and the second one is the angiotensin receptor blockers. They will stop the angiotensin 2 from working. So this one, they cannot be formed. Stop formation. So like, if they doesn't have this, they cannot form anything, right? But for this one, the second one, they have been formed, but they will stop the work. Okay, and for the aliskiren, which is the renin inhibitor, so that they will just stop the renin. Why? Like what I said before, the renin will change the angiotensinogen into the angiotensin 1, and then they will also like change from angiotensin 1 into the angiotensin 2, like that. And then we also have the properties of pars ascendens and descendens of Ans and Henle. So for the pars ascendens, it is actively move the salt out of the tubule lumen to enter the interstitial fluid, and also it is more impermeable to the water. But for the pars descendens, doesn't actively secrete any salt, but they also highly permeable to the water. Okay, let's go to the next one, which is the secretion. Secretion has also other names, which is the augmentation. So it's just the same, because there's some book that they said augmentation rather than using the word secretion. So the secretion, it is the transfer of the molecules up to the lumen of the nephron tubules. And the secretion depends on an active membrane transport. Where it happens in DCT, or distal distal tubules. Distal convoluted tubules. Distal convoluted tubule. Okay, so in this one, there's some substance that being secreted. For example, like drugs. Why is being secreted? Because they want to remove the foreign the foreign compounds, and then they also did to the food colorants because they want to remove any artificial chemicals, and then for the ammonia and creatinine because it's the metabolic waste. So like, why don't we just like throw them away? And then excess hydrogen also like potassium. Okay, and then next to the so we need to know that the kidney works against the concentrations of the gradient. Why? Because it pushed the waste into the tubule even if the waste is already already high in urine. Maybe some of you will still like, what is the difference between reabsorption and also secretion? So if we're talking about the versus secretion, this one is reabsorption. Okay, for the direction, we will talk about the direction first. Okay, and then the purpose also examples. So for the reabsorption, in the direction they will go from the tubule to the blood. Why? Because they want to take the important things into the blood again, so to save those important, but I need to inform you, if anything that goes into the tubule is something that is more into the fluid, okay? But if blood, it means that they still need those things. So that's why if tubule, it means that this fluid will be the urine. So that's why they will save from the important one into the blood again. But for the secretion, it is the opposite. So like, it goes from the blood to secretion, because it could be like there's some components that's actually not important again. So they will take the one from the blood into the tubule. Blood into the tubule, and they will just like throw them away to remove them, because they're not important again. For example, in this one is like glucose, water, so Na plus. This one is like drugs, and others like this one this one. Okay, let's go to the next one, which is excretion. Excretion, the elimination of substance from the body in the form of urine. Urine is the last formations of the excretion. And excretion is not a spirited process, but it rather the result of the three preceding process. So excretion is not the part. So like, if we are talking about the process only filtration, and then they will go into reabsorption, and then the last one is secretion. So like, the excretion is just the result. The result is the urine itself. The urine, for example, like that. If you how to know what is the result is actually filtration minus reabsorption plus secretion. Okay, like that. And then what is actually being excreted in the final urine? Oh, this one. For example, I think you need to look in this first. In the primary urine, they consist of glucose, salt, sodium, kalium, and also amino acids. But the things that being left out from the original blood is the albumin. So like minus albumin, because the albumin is too big. And then in the secondary, which is in the reabsorption, they did it again. They take some of the important things back because why you should go like remove them, right? And they just the compositions of the secondary one is water, salt, urea, and biopigments. Okay, and after that, for the real urine itself, they have the water, salt, urea, and other residual substances such as like drugs and others. Yeah, those things. And the one who give the colors of the urine is this one. The biopigments is the one who urine color. And urea is the one who gives the smell. Okay. Okay, wait. So, if you want to know the complete process, let's see this one again. This start with in the filtration, in the glomerulus. And then it will form something which is the primary one, primary urine, but it minus albumin. Yeah, but they have like glucose, salt. I think you need to know about that as well. Like you need to remember some things that still exist and the things that being filtered. And in the reabsorption, they're located in the PCT, which is the proximal tubule, and in the loop of Henle, and also in the distal consolidated tubule. So like the body will take the 99% of the water and all the glucose and also more sodium back because they need it. That's still important. And then they will do the secretion in DCT, which is the distal. So the body adds more like waste ions like hydrogen ions, potassium ions, drugs, ammonia. Urea is not the one who gives the smell. Sorry. Urea is just urea, okay? The one who gives the smell is that ammonia. Smell of urine. And then in the secretion, which is located in the urethra, excretion located in urethra. We'll just contain the final urine. For the RAAS, if you feel dehydrated, the RAAS will be activated. So the aldosterone will be released, the kidney reabsorb more sodium, and the water will also follow. So that's why you make more concentrated urine or darkly yellow. So that's why I think you can also like compare when you eat a lot. If you drink a lot versus when you drink not much. Usually when you drink a lot, the colors usually just white, but it could be like have slightly yellow because the concentrations of the water is high. Because because we have drink a lot, so like the body is not need too much water again. So that's why like they just like go remove them, and because they have a lot of water that have been like mixed with the bile pigments, that the one that give the colors of the urine, so that's why it's not that yellow. And then let's go to the next one, which is the kidney clearance. Okay, for the kidney clearance, so the plasma clearance of the substance is defined as the volume of the plasma that is completely clear of the substance by the kidney per minute. So it represents the volume of the plasma from which the substance has been removed. So the plasma clearance reflects the effectiveness of the kidney in removing various substances from the internal environment. So this one is the formula, but you don't need to know too much. So this the use of the clearance of a substance is that to freely filter, and the one that was that being reabsorbed, the one that has not been secreted. So the gold standard is to usually for the urine inulin clearance. Sorry. Not important. Wait. Yeah, this one usually for the urine and blood test. Yeah, so like the U is the concentration and the V is the flow rate and the plasma is plasma concentration. Okay, this one is the sample preparation, but I think it's a bit different with this one. So yeah, I think that's all for that. Assalamualaikum warahmatullahi wabarakatuh. For the pretest kisi-kisi, I will just send you to the group. Bye bye.